Okay, so this is definitely one of the harder optimization problems. The ones that use this as formula, first of all, it's not that obvious, and second, the calculations can be kind of crazy. So I'm trying to show you an easier way to do the calculations. Maybe it's easier to do. So let's jump right in. Just to review, here are the general steps for optimization problems. Okay, so first step, we always want to find the primary equation. Think about what's being maximized or minimized. In this case, they don't really tell you. It's kind of implied that if you're trying to find points on the curve, on the parabola that are closest to the point 18, 0, then what you're really doing is minimizing the distance. Okay, and so that's why we need the distance formula. Okay, then we can start. So the thing with this is that there's actually 4 variables to have to work with. Okay, so there's a long ways to go. But right away, the problem already tells you the point 18, 0. So you can say this is x2 and y2 if you want. Actually, I'll do it the other way. X1, y1, plug that in. And they give you already a secondary equation. That's step 2. That's already given. So we'll say this is y sub 1 then, and we'll plug everything in, see what happens. So x2, we don't know. I'm going to call it x, leave it as x. But x1 will be 18 plus y2. Sorry, this equation should have been y2. So I'll plug in x squared for y2 minus y sub 1 is 0. Okay, so now, all right, let me just go simplify some more here. Okay, so at this point, we're ready for step 3, where you use the first derivative test on the primary equation, because we have this equation down. We have the distance equation in terms of x only. And so we're ready to take the derivative, do the whole first derivative test. All right. But the thing is, if you were to do that, this is a square root equation with quadratic and a 4th degree equation here. The chain rule for this would be crazy. So there's one key step, one special step you can do for these distance formula problems, okay? So to make this easier, you can actually go ahead and square both sides. Okay, so this is the kind of the magic move here. Square both sides. It'll be a lot easier to work with before you take the derivative. All right, so now we can take the derivative. It is doing implicit differentiation. You're gonna use power rule on both sides. Okay, including, finding the derivative distance. So that's going to be 2d. Here's a key step though. Kind of, you have to apply the chain rule on the variable d itself. That's d over dx. Okay, and the rest of the way, let's go ahead and do the derivative as usual. Okay, your goal, remember, the whole point of finding derivative is to find dx. So we have to isolate this part, okay? Which means you just go ahead and divide both sides by 2d. Okay. So I'm going to go ahead and already sort of simplify stuff. So at this point, remember, we're doing the first derivative test, which means the next step after that, after you find a derivative, you set the derivative equals 0. Okay. Now, the bottom here, there's a variable already inside this derivative. That's d. D refers to the original equation that we set up here. It will be this one. Okay, this is d. And you could bring it in as part of this big fraction, but it's unnecessary because now you can just multiply both sides by 2d. That gets, 2d times 0, anything multiplied by 0 will be 0. So that's basically trashed. Okay, it's become 0. So now you can also divide both sides by 2. And what we have here is a, it's a mistake here. We have a cubic function. Okay, we have a cubic function. Can't really solve this by hand. Well, the only way you can do is to use a PQ test, find all the factors, synthetic division, and all that. If you want a shorter way, use Desmos to graph it out to find your zeros. Okay, but I'm gonna tell you right now, save time, that a factor that does work will be 2. So let's see what that looks like. 2, 0, 1, negative 18, 2, 4, 4, 8, 9, 18. There you go. How nice. You do end up with the quadratic equation like that. Can't factor this, but if you keep using the quadratic formula, you'll see that these give you imaginary roots. All right, so to save you the time, I'm gonna say the only factor there is x equals 2, which means if you plug it back into the original equation, y equals x squared, then y equals 4. And so, that will be, coordinate point will be your answer. Okay. So this is a special step for distance formula problem. You square both sides before you take the derivative. That'll make the calculations easier. Okay.